Okay, let's go ahead and get started, and so we can go through this. Hope you enjoyed your weekend not having a quiz, but I do want to take some time and review so we can get back together and kind of get back on track, since normally I would have used the quiz as a review. So going through the surface area, those sections 3 and 4, surface area of prisms and cylinders. Key thing, a prism has two bases, which means they're parallel. And like I said, this is just kind of a general review of everything. Two bases that are parallel, and the sides, the other faces, are usually rectangles or parallelograms. And the biggest difference here, this one, the two bases are still parallel, but they are circles. They are circles. These are polygons. Could be any shape. Squares, rectangles, hexagons, triangles, it doesn't matter. It could be any shape. Taking that, we really had two basic formulas. One, the lateral area, and that's the area of the rectangles. Rectangles are non-bases. I'll put it that way. Maybe that might be easier. Non-bases. And this total surface area. That covers the whole thing. So basically, there's your two parts of the formula. And if you notice in some of these questions, they asked only for lateral. Sometimes they ask for surface area. They really go hand in hand. And it has a lot to figure out from some other things. So going through, lateral is always the perimeter times the height. Perimeter of a base. And it's only one of them. You don't need the perimeter of the first one and the second one. It's the perimeter is the perimeter for both of them. It's not doubled. So it's the perimeter of the base. And the H is the height. But in this case, the height is distance between parallel bases. Remember, it's always the perpendicular distance. So when I mentioned height on that one, and they got a lot of different numbers in there, you're looking at the difference between the two the ones you're calling the bases. That is the height. Surface area is really everything. So we have the lateral, that's all those rectangles, plus I have two bases. So there's your general formula for surface area. But on the key thing on this one, that B is the area of the base. Not doubled. Well, we're doubling because of this, but not doubled within the formula. That is chapter 11. Any of those formulas from chapter 11, because that base is a polygon or a circle. So if you have those two down and know how to find the area from chapter 11, everything is there. Everything is kind of in a review mode at that point. If I want to get specific, the cylinder and the prism is generally the same, but if I want to go specific and have another set of formulas to memorize, but you don't have to memorize if you know this one. The lateral is the perimeter for a circle is circumference times the height. Circumference is 2 pi r times the height. So there's the specifically to the cylinder, but if you remember that it's the perimeter times the height, we have that one. The surface area, the lateral, if I want to go specific, 2 pi r h plus 2 area of the base, area of a circle is pi r squared. Those are specific to the cylinder, but if you memorize the two general ones and know those formulas from chapter 11, it's all I've done is just apply them in. Didn't do anything else. Okay, so those are the things I'm going to be using going through the homework from 12.3 and 12.4. First ones, find the lateral and surface area. If they ask for surface area, you still have to find the lateral, but if they only ask, you only have to find the laterals. So that's kind of where you have to watch the directions. Round to the nearest tenth. Now, this is a rectangular prism. Now, this one kind of depends on, remember I said bases. There are two parallel faces, if you want to put it that way. Some differences could be found. I can do this as my base and the one in the back. You'll probably find me doing those two, but that doesn't mean it's always the case. A lot of times it may be determining the numbers. If I use those two, the 6 by 7 as my base, the height is right here. The distance between there, the height would be 9. And remember, I need the perimeter times the height. And there's my perimeter. There's my height. Then, since I'm using the base that was a 6 by 7, the area of my base is 42. Now I can plug in here, here, and I get that. Now, something to keep in mind. Rectangular prisms, you can get away with this. The other ones, you can't. Rectangular prisms, these can have different lateral areas. Because maybe you don't like to use the front and back as your bases. Maybe you decided, I really don't like the back. I'm going to go traditional. My base is the top and bottom. Which means it's a 7 by 9 base. 7 by 9 base. So this one you have to be careful, and I will keep in track because it is a rectangular prism. Okay, again, my lateral. If it's 7 by 9, that means my perimeter is 2 of the 7s plus 2 of the 9s. But my height is between the bottom and the top, which is 6. So that gives me 14 plus 16 times 6. If I'm adding right. 14 plus 18, sorry. Can't read my handwriting today. (32 times 6). So my lateral is 192. different from that one. But that's okay. This is a perspective. It can have different lateral areas. But what ends up happening if I do my surface area, base is 7 times 9, which is 63. So I get 192 plus 2 times 63. I still get 318. Surface area will be the same. So on this one, for example, there could possibly have been 3 different lateral areas, and I'll do the other one in a minute. But if I asked it and said it's a rectangular prism, everybody would get the same surface area. It's the same box to cover. Surface areas you're covering. You're covering the box. It's the same box. It depends. Probably have received presents over the years in a box. Sometimes they have them tall and skinny, it looks like, but I could have laid it down and be just long and skinny. Or whatever the case may be. It's the same box, whether it's standing up or laying down. And if I do, we did the front and back, left, top and bottom. If I say my base is the right and left kind of perspective, that one and the one back here, and that would be 6 by 9, 6 by 9, which now tells me if it's a 6 by 9, the distance between them is 7. The hard part is getting their perspective, which one is the height for its size. The height changes. So remember, height is always the distance between the two bases. So whichever base you choose, that's the one you work with. You can't do half of one and half a base of the other. So if I do that right and left as the base, it's a 6 by 9. My perimeter is 2 times 6 plus 2 times 9, 12 plus 18, which is 30. My lateral would be 30 times 7, or 210. My surface area, well, my base now is 6 times 9, which is 54, because I'm doing the area of the rectangle I'm referring to. So surface area equals 210 plus 2 times 54, which is 210 plus 108, 318. So on that one, that particular homework problem, and there's another one that we see anytime if it's a rectangular prism. That's the reason I want to stick with that one. That's the only case this is going to work on. In other words, I can have multiple laterals. Here's a lateral. Here's a lateral. Here's a lateral. Those are 3 totally different numbers, but they all had the same surface area. Questions on that one? Mainly I want to talk about that one just because of the way it's one of those cases, one answer doesn't always fit. And it doesn't for the lateral. It does for the surface area, but not for the lateral. So one answer does not always fit. Anyone with questions on that one? Okay, on this one, another one of those, but I only need the lateral. Need the lateral. They did it again anytime they have that. So if I do, this one's the 3 by 4 as my base. I'm not going to go through all the sets again because you already saw it's done the same way pretty much as number 4 for the lateral. Now remember, if I pick a base, my bases, 3 by 4, I said was these front and back. If I decided to say my base is that 4 by 12, the bottom and top, that means my height between those two is 3. So my lateral be 96. I'm just going to give you that answer. We've done the same thing. If I pick my base to be the left and right, kind of looking at it as looking at a box, the left side and the right side. That'd be this one and that one. That tells me my height is 4. So my lateral is 120. All 3 of those answers are right. It does not say find all 3 possibilities. Find all the lateral areas. But depending on your perspective, so you could have had any one of those 3 answers. Bases are always parallel. Bases have to be parallel. In a rectangular prism, it's kind of nice, but I got 3 sets of parallel lines, parallel bases. Told you this one would come up a few times. So again, not one answer only. Number 8. Number 8, I'm going to erase some of this. This time, yes, it's a prism. But this is a triangular prism. Kind of reviewing those words from the first section. That's why I'm going a little bit slow on this one. Triangular prism. My triangles are my parallel sides. The other ones, if you have a box that looks like that, this is not parallel to either one of those other sides. This side here is like the slit, if you want to way, is not parallel. That back one that's up there in the back, it's not parallel to both these. It intersects somewhere. So that one lateral. Anything else that's not rectangular, you know there's one lateral answer. And I still have my one surface area, but I don't need that one anyway. But we got to find the surface, the lateral area. Lateral equals the perimeter times the height. Perimeter of the base. So I got to go here, that's a base, that's a base, there's a base, but I have no idea how to get that base. That base is not there. It's not there. But if you notice, I just highlighted, I have a right triangle. This comes in anything we've had in the past. Anytime we had a right triangle and said to find a missing side, that's Pythagorean theorem. For missing sides. So this would be my missing side. That happens to be the hypotenuse. So there's my missing side. Sometimes they don't give you all the details, but you should have all the details to find the missing pieces. So I now know what this side is. It's 10.63. I can get my perimeter by adding those 3 sides up. Takes care of the perimeter. Height. Remember, this is the height because that's the distance between the back and the one in the front. So there's my lateral. Remember, this is going to, well, it works out exactly, but I'd say at least to the 10th. Don't go out any farther because this actually would have gone out farther. Okay, number 10, the fun one. I think this one is fun, but it's not your typical picture that we've showed about prism. It's a dodecagon, rather, 12-sided prism. Dodecagon because there's 12 sides to that shape. But it's a prism. I'm still doing lateral. Perimeter times the height. If this is my base, because nothing else is going to be parallel, they're always intersecting something. That's my base, and the one that matches it in the back here, matches it. Those are my bases. Didn't ask for the area of the base. We're only doing lateral, which is perimeter and the height. So the distance between those two, this would be my height. It's the distance from the front back here to the back. The hard part. Get all those sides. Well, this is a 7. They're not trying to trick. It's a 1/4 inch difference or a 1/4 centimeter difference. These have to match. These have to match. These have to match. Everything is nice and matching. These match. So does this one. Both of those. Everything matches. That is the hardest part. Is getting which one is the height and then matching all what pieces and adding those numbers. Because when you add up all those 7, 2, plus 2, plus 4, plus 2, plus 2, plus 7, plus 2, plus 2, plus 4, plus 2, plus 2, that's 38. That's another hard part, but that's the hard part. And I have my height of 9, which gives me 342. Questions on any of those? Anybody? Anyone with questions so far? Are we set? Okay, and the next one's word problems. But we're filling in. Surface area equals the lateral plus the 2 bases of a cube. Cube is again is a hexahedron. So I'm taking every word, showing where the clues come in, because that's the hard part of a word problem. Hexahedron made up of 6 squares. And I want to find the edge of the cube. Well, remember with the cube, if they're all squares, all those sides have to be the same. So I'm just X, X, X. Go around marking X's. They're all the same. All the same because it's a square. All 6 are squares. So perimeter of a square is 4 times X in this case. Area, which is the area of a square, which in this case is my base, is the side squared, or X squared, since I used X for the variable. So I'm really just going to work with this. Lateral equals the perimeter times the height. Perimeter is 4x. My height, if I use the front to back, is x, and it doesn't matter if I go top to bottom, front to back, right to left, like we were doing before, because they're all x's. So that gives me that for my lateral. And I'm just filling in. That gives me 4x squared. I have two bases of x squared. Now I'm just solving, so x is 12. X is 12. And if you used a different letter, that's fine. I just used X. You could have used E for edge. You could have used S for side. Doesn't really matter. 14 is similar, but this one I would call a algebra problem, but a puzzle. And this is another one of those. One answer doesn't fit. Rectangular prism. We talked about that. Lateral area. Okay, the lateral area. Lateral equals the perimeter times the height. Remember I said, depending on the size, we could have different ones. So this is my height. I already have that. That's 13. I've got to find all the possible perimeters like I was doing on number 4 and 6 earlier. So I do, and this is where the algebra comes in. 156 is my total square inches for the lateral. Perimeter for a rectangle is 2L plus 2W. And I divide both sides by 13. You could do this different ways for the algebra, but I just did it this way. Can't solve it to find specifically 1L or 1W, but I can find in general what is L and W got to relate to by taking out a 2, divide both sides by 2, and I get this. So this is the relationship between the length and width, and I could have done base and height, doesn't matter. So they're looking for whole numbers. Well, whole numbers by definition are 0, 1, 2, 3, ... They're looking for possible ones. It didn't say all of them. If I put in 0, first of all, I can't have a side with a length of 0. I have to have something. So this one's ruled out. This is the puzzle side, but it's not really a true puzzle, but it can be. I can't have 0, but now I can see, well, what happens if I have a 1? Well, if I have a 1, 1 plus what number give me 6? If this is 1, this has to be 5. What if and I'm saying whole numbers, I don't have to deal with fractions. If I have a 2, 2 plus what number would give me 6? 4. And then, let's see what else. 3 plus what number? Well, another 3. 3 and 3 would give me 6. If I do 4, I really just end up repeating. If I say, well, what if it was 7? But my perimeter has to add up to 6. Negative 1. I can't have negative length. Algebra I could, but I can't have negative length in geometry. So anything bigger than 6 is not going to work. And between 4 and 5 and 6, they repeat. So there's all your possible values. There's all the possibles. Then you would have had 3 different lateral areas or lateral possibilities to get that same number. Okay? So something to keep in mind, but that's how you would do something like that when it says, what is the possible? I had some emails over the weekend while I was at the conference, and there were some people that had gotten stuck with that. It's not, again, it's not a one answer. There's a lot of geometry, there's multiple answers. Just like when we did proofs, there are multiple ways of doing it. So those are the possible combinations. 1 and 5, 2 and 4, 3 and 3. And you might have wrote it like I did, dimensions 5 by 1, 4 by 2, 3 by 3. It's another way of writing it. Okay, these next group pretty much are the same thing we did before, except this time do everything. The earlier ones were were lateral areas only. This one is surface area, which really means I have to do lateral and surface area. So, triangular prism. Here's my triangle. That's the only ones that could be parallel. So that makes this one the height because that's the distance from here to the two triangles. Problem is, area of a triangle is half the base times height. And base and height have to be perpendicular. So I don't know this one because I remember for area I have to find that. And for perimeter, I still have to find that. So I have to find that before I can do much of anything. I have a missing piece, total sides. So, like we said otherwise, I have a right triangle, Pythagorean theorem. So that tells me this is 15. That's 15. So I add those three sides up, I have my perimeter. Gives me 40. Area, half the base times height, half of 8 and 15. These are the ones that are perpendicular. There's my perimeter. So that gets me my perimeter and gets me my lateral area. And the area of the base is half the base times height. This was chapter 11. There's my area of the base. But surface area, add those up. So those are the steps you still have to take in between steps. Even though I didn't ask for lateral area, you need it in order to get the surface area. $18. This one was like number 4. I'm going to do it at 1, but it gives you an idea. I'm using probably this one. This one is my bases. My bases are 4 by 11. If you use the other one, it's not wrong, but make sure you follow through correctly. So there's my lateral. But giving from that, there's my area of the base times 11. There's my surface area. No matter which lateral you use, this is going to be the surface area. So again, if I use my base as being top and bottom, I'll just do that one real quick. It's 4 by 7.5, 11 by 7.5. My lateral is 2 times 11 plus 2 times 7.5. All that times 4. And still my surface area is 148 plus 2 times 11 times 7.5. still give you that. Okay, so you don't have to pick the one I picked for lateral, but your final surface area will have to be the same on a rectangular prism. Emphasis, rectangular prism. This is only. You could possibly, depending on the measurements, but they're different. 3 different laterals. Area. Same surface area. So if my lateral is different, it's okay, providing your surface area totals out. That is the rectangular. Does not work on anything else. Has to be in the rectangular prism form. You don't have those choices in the other shapes. Okay, number 20. This one is a good one for a general review of everything. Again, trapezoid. Oh. Prism. This is parallel to that. That's it. Because you have 2 other bases, but again, bases have to be parallel and congruent. So that's why it can't be the right and left. It has to be the back trapezoids or the trapezoids. So I'm going to need perimeter of the trapezoid. And I'm going to need the area of the trapezoid, which is 1/2 the height of the trapezoid times the sum of the bases. Bases are parallel within the trapezoid. So there's some things that are missing. This is the height of the prism. So there are things that are missing though. I don't have a perimeter. I know it's 5 here, 5, 9 here, but I don't have a clue on these 2 sides. So taking that, I'm kind of drawing in a little bit. Start breaking up a little bit so you can see it. This side is 9, this is 5. Keep these. I draw a little line here. This is 5, this has to be 4. Because 5 plus 4 equals 9. So I'm all right here. I can get those dimensions pretty well. These are going to be the same. So I have a 30, 60, 90 triangle. Across from here is x. Across from here is 2x. Across from the hypotenuse. And this is x square roots of 3. I know this is 4. This is 8. And this one is 4 square roots of 3. So I'm filling in. The slanted side is 8. The height, or this one, is the 4 square roots of 3. Because it's the one that's perpendicular. Now I have my perimeter. Now I have my height of my trapezoid. So I could fill in that information. Start filling it in. So this comes from that drawing. Taking things like we would have done last chapter. 30, 60, 90 triangle. Now there's my lateral. Add up those numbers. Multiply by 11. There's the lateral. And to find the area of the trapezoid, there's the area of the trapezoid, which is my B. B means the area of the prism, base of the prism. And putting those together. These last three were kind of your common word problems, which you're dealing with a lot for surface area. It says a gallon of paint costs $16 and covers 400 square feet. 2 coats are recommended for even coverage. The room is to be painted is 10 feet high. Kind of a drawing of the room. Kind of imagine you're looking at your room three-dimensionally. It's 10 feet high, 15 feet long, 15 feet wide. Typically what you would think of if you're drawing your room. Only you have 1.5 gallons of paint left to paint the room. And they want to know, is that enough to paint the wall? Okay, key thing, if it's the walls only, that is the lateral. That is the lateral surface area. So if I calculate my lateral surface area, I find that I need 600 square feet. This is from the room, the lateral, but 1.5 gallons is not enough for 1 coat, because 1 gallon up here covers 400. Half a gallon for that 1.5 covers 200. So that goes 600 square feet for 1.5 gallons, but I need 2 coats. So I really need 1,200, enough to cover 1,200 square feet. So it's not enough to cover 2 coats. It is for 1, but not for 2. Then in question 2, how many gallons to paint the walls? We just kind of did that. So that total coverage is at 1,200. Each one covers at 400, so I need 3 gallons for the 2 coats. Now this one, it's a combination. It's to paint the walls and ceiling. So I've got the walls, area of the walls, which is my lateral, plus 1 base, because it's the ceiling. It's not the full surface area because you're not painting the floor. So you think about what you're painting. How much would it cost? Well, the ceiling area is the same as the floor. That's going to be the 15 by 15 area ceiling. So that's 225 square feet. And then I already know I need 3 here for the walls. So it takes 2 coats. That'd be 450 square feet. So I need 1.25 gallons. If I can only buy whole gallons, that means I have to buy 2 gallons. Can only buy whole gallons. That's the reason I went ahead and rounded to the 2. So I have 2 gallons here, 3 gallons here. Each gallon costs $16. So the cost would be $80. Okay, questions on that one? I know I'm taking time, but I'm doing it kind of slow to make sure we didn't have a quiz or anything to cover it, to go over it either, so. Because this section, the difference is cylinders. Perimeter is the circumference. Remember I said that's the biggest difference, which is 2 pi r or pi d. Area of a circle, which is the base, is pi r squared. So you could do it specifically, memorize that set of direct formulas, or you can do just remembering the general statements. So I'm going to go kind of fast on these. Surface area, this one I may take a little bit. Has with a radius of 4 feet, height is 6. Remember what I said? There's this lateral. And you're going to notice, and it's the easier, I believe, keep pi as pi until the last step. Keep pi as pi until last step when you round. If you do that, you have less writing of numbers and keeps the accuracy. Area of the base. Now I'm filling into that formula. This is why I did what I did. I kept pi all the way through till I got to the last step. Then I let the calculator do 80 times pi. 80 times the pi key. And 6, doing the same thing, but this time it's an algebra problem. When I start filling, I fill in what I know, and this is the only things I do know. Then I start. Remember, when you start getting an r squared and an r, it has to equal 0, and then you can solve by factoring or quadratic formula. If it's factorable, it doesn't matter. If it's not factorable, quadratic formula is the only way you can get an answer. Can't have negative length. There's my answer. Okay, number 8, word problem. Collecting labels. The students collected this many total. Here's the dimensions. The can, 4 inches high. The diameter, 2.5 inches. Find the total area. When you're finding something like this, you're only finding the lateral. That's the key thing. You're only finding the lateral area because you're only talking about the labels. They did not say anything about they wanted to find the area of the labels. Labels only go on a can, if you think about it, on the sides. So I need to find the area of one label, and that's the lateral. That's lateral equals the circumference times the height. And I'm just going to go ahead and fill that one in. Again, I'm going to do the leave it as 1, leave it as pi. So my lateral, I did the height. They said that. Here's the circumference. I needed that. Fill it in. Here's the area of one label. This is one label. And I think I probably spelled wrong, but it looks wrong. Just one of those things all of a sudden just looked wrong in the spelling. I need the total area, but there are 3,258 cans. Every one of them is 10 pi. That amount, there's your total area. Okay, number 10, just keep a reminder, that's diameter. Lateral is perimeter times the height. Diameter can be, the circumference can be pi d, so I didn't have to do anything there. But I do have to do over here, radius is going to be 6.8 because the area is the radius. Have to have the radius. Radius is not the same thing as radius squared is not the diameter. Just like we were doing in last chapter. So there's the final. $12, same thing. This time they put it, notice it was radius, so you don't have to worry about it. 2 pi r per circumference. There's the area of the base, the circle. There's the surface area. This is rounded to the 10th. Not exact, rounded to 10th. And that's how you can tell by looking at it. Okay, number 14. Again, there's my circles. Here's my height. This is the diameter. Notice it's got the line going all the way across. If you look at number 13, it only went part of the way. So that is the diameter. So you got to keep that in mind. So there's my lateral. Because pi d is circumference. But again, that is the radius equals 4.1 for the area. There's a surface area. And 16, my book kind of marked it as a hard problem, but if you got to think about it, you got a circle, and this is just a can on its side. Here it's still a cylinder. There's a circle, there's a circle. If it bothers you when you see things turn like that, turn it around. So now I have, this is my height, this is still my diameter. So I just turned it so that it looked like a cylinder. If I think of cylinder being the top and bottom being the circles. If you're remembering that the cylinder is based off 2 parallel circles, it doesn't matter. But sometimes it's easier to see that way. Then it's just like the previous ones. There's the lateral. There's the area of that base. There's the surface area. So if something in your mind you want to say you're always talking about bases being top and bottom, you can always mentally turn it up or turn your book or something so it looks like it's up and down like you would think of as a can. Probably would not leave a can like this because it's going to probably roll off. If you think of it as being a can, a tuna can or something. Because this one I consider like a tuna can on its side. Tuna fish can. And number 18, finding the radius. This word problems. Again, I know what this is. I know what this is. My lateral. I just filled in all my formulas, started filling in what I could. This is go specific. Given info. Did that, but again, I got those R squareds. I did factoring. If you have a difficult time with factoring, go with quadratic formula. It's a good thing to start practicing because it is a section you're going to be doing in Algebra 2 for those that continue in Algebra 2. And this one, same thing. Went specific. Filled in. Problem is, yes, I have R squareds, but I have these numbers. Anytime you have decimals in X, unless you catch the formula, they have to be a nice combination of numbers that would multiply together and it's even. Maybe multiplying everything by 10, you could try it. You can multiply to clear. It's called clearing fractions, but you're really clearing decimals. Or I would definitely at that point, if I had to do that much to get ready to factor it and get those big of numbers, do the quadratic formula. And by the way, this is the quadratic formula. I will not test on it, but I want you to see it for those that are going to Algebra 2 next year. So it is, at least you've seen it. Then I'm filling in. That's what I refer to this quadratic formula. And that's fill in from x squared, that's what I'm referring to as the a, plus bx plus c equals 0. Signs have to go with it. So that's why this has to be plus a negative. So it's a little bit of algebra review. This means add or subtract. So you do it once through one time with adding, then come back and do subtracting those numbers. But when you subtract, you get get a negative. So it's approximately 5.5. It's not exact. So that's why typically if I see decimals, I'm going to go quadratic formula almost every time, unless it's some small enough that I can multiply by 10 and maybe clear the decimals. But the numbers start getting big, do the quadratic formula. Tips along the way. Okay, any questions? Because today we're going to do, okay, good. Pyramids and cones. Again, I'm putting two of them together. Putting two of them together. Key difference. This is made up of polygons. Triangles form the point. Come to a point. Cones, and named by the base. Polygon. Cone, biggest difference. It's not a polyhedron. The base is a circle. Base is a circle. So we're going to do a lot of more things to it, but just want to work our way through. So there's my pyramid. This is my cone. The lateral area. And I'm doing, I will do this in words so you can see it, but sometimes I think the pictures are easier, but whatever. So you'll see both. Lateral surface are the triangles that form the peak, if you want to think of it that way. All these sides. That's the lateral surface. So all those triangles that form that peak. On a cone, you have to think of it's like a birthday hat. Or party hat, whatever you want to call it. Party hat. That's the lateral surface. The base is the polygon on a pyramid. Base over here is a circle. Now we're going to have, if you notice, it's easier to see on this one, but same on both of these are going to be the same. Height. Height is always perpendicular to the base. Height is always perpendicular to the base. Yeah, I heard you had fun with yours too this weekend. Height is perpendicular to the base. But when I'm doing the area of the laterals, remember, area of a triangle is half little b and still base and height and perpendicular. So area of a triangle is half the base times height. Well, the slant height is the height of the triangles. Or on a cone, you kind of visualize it. You can see it. It's that slant height, but it's the height of the triangles over here. So if I put it right through here, it's the height of that triangle. So that was the slant height. So now I can get my area of my triangles because I have my base, go around like we did before. So that's kind of right there. If you keep these things in mind, you've got the notes. Got the bulk of the notes. Lateral, again, all those faces except for the base intersect at one point, all the faces. And those faces, the base is always a polygon. The faces are triangles. Some of this, we've talked about it before. This is a little bit of the review from section 1, but kind of tying in with the words lateral. The vertex, and I'll go back to that page, get more detail. Typically, this is the key vertex. This is the only vertex in a cone. We could have other vertices here. But all of these are faces. And then we have our base. Get my picture nice and messy. Edges are where those things come together. Those are the edges. Kind of can see the triangles at that point when you look at the edges. Altitude is always from the vertex that key one, perpendicular to the base. Height. That's the capital H. The height of the lateral face is the slant height. It's usually a slanted L. That's the height of the triangle. So I get the half times height. That's the slant height. So it's two different heights. One's the height of the overall 3D shape, one's the height of the triangle, the side. And I'm going to go through the ones for the cone same time. Base, biggest difference, it's a circle. Vertex is the point, only point. The axis, this one's probably a minor word, but it's the endpoints where the vertex into the center of the base. Sometimes you use that, sure you know where it's at, we're referring to. So it's like if you stuck a straw in through your cone and kept it centered, that's what you're doing. That is the axis. But the segment that I'm worried about, this one more, again, it's the altitude. It's from the vertex perpendicular to the base. That's the altitude. going to the side of to the circle, joining the vertex to the edge, join the circular base. That is the slant height. You kind of see that triangle formed. That is the slant height. So we have angles that make up the lateral. We have our one base. That's all I have because it's a cone or a pyramid. One base. So I can start doing my calculations. Surface area of a pyramid is the lateral plus the base. I have the things that come up, the sides that come up to the point, and I have the bottom. The key one, remember I said the lateral is made up of triangles. So area of a triangle is half the base times height. So the formula for the lateral is 1/2 the perimeter times the slant height. The perimeter is all the bases of the triangles, individual triangles. The slant height is the height of the triangle. Area of a triangle is 1/2 the base times height. So we just do that instead of doing them all up individually, we just do the perimeter. That way we just take care of it one time. So that is the surface area. Lateral plus one base. That's all I have, one base. And guess what? On a cone, lateral plus one base. The difference is this is a circle. This is a polygon. So we got to think about, again, a circle, perimeter for polygons. Circumference for circles. Kind of means the same thing. So my lateral would be 1/2 CL, where L is at slant height. Now I can, if I remember those, I really have my formulas down. But if you really want to get specific, I can go ahead and get this. This is the one, if you really know it, it doesn't matter. But if you want to memorize another set of formulas for the cone, so I have 1/2 circumference is 2 pi r times my slant height. And when I do that, this is the lateral specifically to the cone, specifically matched to the cone. Area of a circle, the base is pi r squared. So if I want to get specific for the surface area, this is my lateral plus my base. I think the book uses this one. But as far as I'm concerned, if you know this and can do this, which we're all basically chapter 11 and before, 10 and 11, you don't have to memorize another set of formulas. You really have the same ones, both cases. So I'm trying to keep the numbers of formulas down, but you got to, they're weaving together. You have to know when to use which. So for example, there is a pyramid. We're going to work together to find some. Remember, I need lateral, which is 1/2 PL. And then I need surface area. Well, first of all, let's get something out of the way. What's the perimeter of the base? Some of you are answering private chat. What is the perimeter of that base? that base. And it says regular, so you know that whatever is across from each other, it's at least the same. You're not going to change up stuff. What is the perimeter of that drawing? What is the perimeter of the base? In private chat. No, I have 8. So I have for the base 4 times 8 because it's a square. It's 32. So I got this one checked off. If you're trying, you're not sure if it's right, send me the answer and then we can work with it, okay? I'm taking this in very small little bits. I know that's my lateral. I have to do surface area equals the lateral plus the base. So I'm just trying to get the lateral out of the way. But the lateral is 1/2 the perimeter times the slant height. Now, the hard part, I have my perimeter. I know what half is. I have to find my slant height. What is the slant height? Any guesses from anybody? Any guesses? What is the slant height? This one is a little tricky. It is tricky. But slant height is right here. Right there. If I could draw, they didn't give a number to it, but the one I'm highlighting is the line is the slant height. It's the height because there's that little right angle. That would be the height of that triangle. And there's my base. But all they told me was this, that. So I'm going to take this and pull it outside a little bit, that triangle, and flatten it out so I can see it and not make it look like it's 3D. This is my slant height. That's the one I pulled that was the slanted side. This is the 4 on the bottom. This is a 6 up here. And just like I said earlier, I have a right triangle. So I could use this forms my. They're always going to give you enough details, but you may have to fall back on information from earlier chapters on how to use that details. So this is Pythagorean theorem. S 4 squared plus 6 squared equals L squared. 16 plus 36, which is 52. So L is the square root of 52. So now I have this. I have my lateral. Lateral equals 1/2 32, because I found that, and the square root of 52. Let my calculator do the work at this point. So that is approximately 115.38. Again, remember we talked about last chapter, or at the beginning of this chapter, when I went over the test, that you should go out at least a couple places for rounding. There's my lateral. So this one's done. Okay. What's the area of the base? Because I need this one. What's the area of that base? In private chat. Looks like it's pretty much, as he said, is an 8 by 8 square. So it's 8 squared, which is 64. So I only have one base, so I have that one. Surface area equals lateral 15.38 plus the 64. And so it gives me that. But remember, they said the nearest tenth. There's my surface area. Take it in pieces and parts. We're not going to work all this next one, but I want to show you some things about this one and kind of remind you. The base on this one is a hexagon. Which means from last chapter, area equals 1/2 AP. Well, this is nice. I need the apothem, or perimeter. That's perimeter, same as before. But I need the apothem. The apothem is from the center to that point. That would be the apothem. That would be the apothems. Things like this are ones I'm trying to give you the drawings. So remember, you would end up doing your triangle. This would be my apothem. This is the side. But if I'm looking 3D, and then again, this is central angle, 360 divided by 6, which is 60, and I have to cut it in half again. So I got 30 and 60. So I have this. This one you got to be a little bit more careful because there's a lot more details. There's my apothem. But I'm still, remember I said they're going to give you enough info, but they may not give you what you want for info. So now I have to step back and find what that side is. But like that other one, there is my triangle. 12 squared plus the apothem squared has to equal the 15 squared, which then you find A is 9. And then you do your 30, 60, 90 triangle and do everything else the same. Okay? But that's why I wanted to take a minute. Sometimes you know your formulas, but then you got to see what's given. How can I get there? Well, if I look here, I see that is the same as the apothem. If I draw that triangle with the slant height, which I already have. That one was nice. They gave me the slant height, but they didn't give me the sides. So now once I have that as a 9. That is square roots of 3. So 9 equals x square roots of 3. So my x is 9 divided by the square root of 3, which is approximately 5.196. But I'm kind of, remember, this is half and half. That was that part. So that makes that whole side 10.392 is the side. So now I can get my perimeter. Perimeter equals 6 times that number. Which is 62.35. That is the hard part. I don't want to do a couple of parts of the hard because then I have my area of the hexagon. I have my lateral is 1/2 the perimeter times the height. These two perimeters are the same. Once I get that perimeter, I can use it 2 places. I know my slant here So I have my lateral. I have my area of the base with the calculator. Then I can put those together. That's one of the things you have to just be a little bit careful with. It's finding perimeter is the perimeter. No matter in that problem, it doesn't change for perimeter of one versus perimeter of something else. So then my surface area would be the lateral plus the base. This is my base. There's my lateral. I'm filling them in. And this last one we'll do with a cone. This is showing the radius. Now, if I look at this, I see a nice triangle. This is my slant height because it's the slanted side of the circle of the cone. I still have to have my big height. But I have Pythagorean theorem. So in that case, the area of the base equals pi times r squared. It's a circle. Gives me that. The lateral, 1/2 the circumference times the slant height. It's 1/2 2 pi r times my slant height, which they gave me. So I really came out a lot better than I would have. And r is 1.4. So that is 4.48 pi. Surface area, add those. 1.96. Remember I said if I got pi, do it pi the last thing. Gives me that. Now use the calculator to figure out that that is approximately 20.2. Okay. Things to keep in mind. Sometimes they give you the height, sometimes they give you the slant height, but if they put it out here, that is the slant height. That is the slant height. So for homework, this is the pyramid. This is the cone. This quiz is Friday. I spent a lot of time doing 3 and 4. This is basically your definitions, knowing what a cone, prism, and how to name it, whatever. This is the prism. This is a cylinder. Review those. But I cut the quiz back because missing last week, rather than having a double quiz, which would have been almost the test, I cut it back so that I'm going to use that quiz and the chapter review and review for the test next week. So when it's completed. The test is next week, but we'll probably have some overlap of 2 chapters. We've got 5 weeks left, so that's about it. So I'm trying to get everything in between this chapter and the next chapter, and they're both fairly short chapters. So if you have questions, you're welcome to stay on and ask. If not, you're welcome to sign off, but feel free to ask. And I'll see you on Wednesday. I remember what day of the week it is.